Hi everyone, this will be the cheat sheet workshop portion to help you build a focus cheat sheet to help you prepare for the final, not the final, the midterm. And why don't we go ahead and start with the forecast. Okay, we started the class by talking about two different types of forecasting techniques. The first one is based upon time to make a demand forecast. So we can say like, based upon past data points, we can say that, oh, next week, we'll expect a certain forecast. The following month, we might expect a different forecast and so forth. And the second one, the second forecasting technique we talked about was the associative model technique, which we are making an association from two variables, the independent x variable and the y variable. So for example, if we're talking about temperature, we can say if it is 100 degrees out, we might expect a higher demand than if it was cooler. We expect a lower demand. Okay, so I'll come back to talking about the associative technique in a second. Let's go ahead and start by focusing time series on the various time series techniques we talked about in this class. Starting with the simplest of techniques, talked about the naive approach. In the naive approach, we're just taking the previous actual data and we are projecting it forward. Again, all the randomness is in the data, so it's not very accurate. And then we talked about several averaging techniques, which uses averages to smoothen out the data to basically eliminate all the random variation that we might have in the actual data. First one of these techniques we talked about is the moving average technique. The second technique we talked about was the weighted. Average technique. And then the third one we talked about was the exponential smoothing technique. I have in the forecasting channel, if you go to one of the first live notes that we did in class, I have a sample for each one of these techniques. And we just deconstructed the example in the textbooks, which will walk you through how to solve these types of problems. That being said, the exponential smoothing is the one that can sometimes confuse students, so I just want to highlight a couple points here. The exponential smoothing technique allows us to consider the fact that there are always errors in our forecasting, and we do that by applying an alpha, which is essentially what percentage of error are we going to accept in our forecasting model. So therefore, the formula for the exponential smoothing is the forecast for a specific period is the forecast for the previous period plus alpha times the actual value of the previous period minus the forecast of the previous period. And again, there are examples of solving these problems in the forecasting channel. All right, so after we talked about these forecasting techniques, we also talked about trend. Trend is when we see a pattern in the data, demand and time, where we might see a trend going up, or we might even see a trend going down. The formula for the trend is just a typical linear regression, which is the forecast for a period t is the y-intercept plus the slope times the time period. Here A is the y-intercept, and B is the slope. And then finally, we talked about the associative model, which has a very similar formula. YC equals the y-intercept plus the slope of the x variable. B is still the slope. A is still the y-intercept. The only difference here is time series. We're dealing with time. In the associative model, we are dealing with a variable. We're saying that there's a relationship between the variable x that causes an impact on variable y. For these types of questions, I've told you that you will not be required to calculate the y-intercept and slope, so I'll be giving you the y-intercept, I'll be giving you the slope, but I will be giving you this problem in such a way where you have to figure out whether or not a problem relates to the time series trend model or the associative model regression method. And then finally, with the forecasting techniques, we had talked about the various forecasting accuracy techniques. So forecast, we also call them summary errors. The first one that we talked about was the mean absolute deviation. The formula for this is basically taking the average of all of the absolutes of the errors and again, there's an example in the forecasting techniques on how to do this. I really advise, kind of creating a table, putting the values, adding it up, dividing it by the numbers to get the average. The second technique we talked about was the mean squared error, which is essentially doing the same thing, except this time we are squaring the errors, so we don't need to do an absolute there. Just squaring all the errors. And the key difference here is that we will want to make sure that, unlike the regular averaging techniques, we want to subtract out one count from the total numbers. And then finally, we also talked about the mean absolute percent errors, which is just turning all of this into a percentage. So we can do something like absolute of the previous one all over the actual t. So this gives us a percentage. And because we're dealing with small numbers, we probably want to go ahead and multiply that by 100. And then because we're dealing with averages, we just want to divide that by the total number of data points that we have available so that we get the average of the mean absolute percentage. Okay, so there are examples of this, again, in the forecasting channel. I would highly recommend, let's see, on your cheat sheet, you definitely want to know the naive approach. We want to know the moving average approach, the weighted moving average approach, the exponential smoothing. We want to know the differences and how to solve the associative and the trend model. Definitely want to know the mean absolute deviation, mean square, and I may probably not give you a question with the mean absolute deviation. Like I said in the last class, the take-home portion will cover these types of questions. So over the next week, you will be getting your hands heavily involved with this if you hadn't already for the take-home assignment that we covered last week. Do keep in consideration that you will, even though you're more than welcome and it's not expected, but you're encouraged to use Excel in the take-home portion. Be prepared to be able to solve these types of problems in the in-class portion too. Next, let's moving right along to capacity planning. There are essentially two different things we talked about when it came to capacity planning. First of all was the resource planning. The resource planning, it's all about knowing the capital D, so we're talking the annual demand of each product. Being able to calculate the processing time to make each product. And then being able to determine how many resources are necessary. How many resources are necessary to meet the expected demand. Okay, so that's one type of question you can expect to see in the midterm. And the second type of questions that you can expect to see are related to the cost, volume, analysis. And with these types of problems, it's really about knowing which one of the formulas that we've talked about in class to use to answer the questions. The big ones are total variable cost equals fixed cost plus total cost. You also know that total cost equals variable cost per unit times quantity. Also know that total revenue is the revenue times quantity. Do this to keep it standard. And then we also know that profit equals total revenue minus total cost. And then there are different ways that we can essentially convert this formula to help you answer the questions. One way we can convert this is that the profit is the quantity times the revenue minus the variable cost per unit minus fixed cost. So if the problem gives you quantity, revenue, variable cost per fixed cost, and the variable cost and fixed cost, and it asks you to determine the profit, this would be the formula that you would want to use because you have all of the necessary components to answer this question. If, however, the question is asking you to determine the quantity based upon the profit that you're trying to meet, then you would want to use this one, which is the quantity equals the profit plus the fixed cost over revenue minus variable costs. And then we also talked about the quantity of the break-even point, which is at what quantity do we need to make to just break even, which is P plus FC all over revenue minus variable cost. Because break-even point means we're making no profit, we can just wipe that out, and so we are left with fixed cost over revenue minus variable costs. So these formulas should all be on your cheat sheet. And an example again of what problems that we can use to solve these problems can be found in the capacity planning channel. Which now brings us to the final topic that will be covered in the midterm, and this is the linear programming. Again, I will be giving you a sneak peek of what the problem that you can expect to see in the midterm tomorrow. Can I paste? Let's see. There we go. This is just taken from our notes from last week. This. Okay. So just be aware of the objective function and how the objective function is calculated, which is adding these values together with the decision variable plus the profit time. In this case, the profit times the number of W models we're making. You get the objective function. And here we know that, understand what the objective function means. In this case, we're saying that we can make the most profits by making 132 H models and 36 W models. Also understand how constraints work. And once again, multiplying the number of each decision variables by their constraint values to get the left-hand side. And then also understand the right-hand side represents the actual constraint itself. Also understand the difference between binding and non-binding constraints. What does that mean? Are these binding or non-binding? The answer to that is they are binding because they equal each other. And then definitely, and you will see additional tables in the take-home portion, in the sneak peek that you will see in the take-home portion that is a part of the actual midterm itself. So understand how all the values in the tables flow up into the actual Excel database, Excel spreadsheet that we solve to get the actual optimal value. Okay, and then we talked about a couple of the reporting. In particular, pay special attention to the sensitivity reports. The sensitivity has two parts. There's the top parts and the bottom parts. Let's see, let's start up here. This is the top portion. And the top portion answers the question of what range are the coefficients? In this case, the coefficients are the profits. At what range will the coefficient allow us to have the current optimal value of 132 H models and 36 W models? Okay, and that's what's referred to as the range of optimality. What range of coefficients allow us to use the optimal decision variable values. Okay, and so how does this work? Well, we see here, if you just look at the report itself and use some common sense, we see, okay, these are the final values that were that we arrived at. Don't worry about the reduced cost. These are the objective coefficients. See here 40 and 30, and if you look at the data, you're like, okay, 40 and 30, I get where that comes from. And then here we see that we're able to increase the value by 20, and we're able to decrease by 30. Okay, so it's just a matter of, in this case, for the H model, the range is 40 minus 30. 40 minus 30 equals 10. And the upper limit is 40 plus 20 for 60. So therefore the range is 10 to 60. Also understand, what does this 10 to 60 mean? There are ways that I can ask a question that will have you determine, that will allow you to solve a problem of applying this to the Excel printout that I'll be providing you. All right, so now the bottom portion of the report of the sensitivity analysis deals with feasibility. And so this answers the question of, not the question, but allows us to identify the range of feasibility. And this range of feasibility answers the question of at what range is, or actually, are the shadow price accurate? Okay, so first talk about the shadow price. Shadow price, let's see, it's provided to you right there. Shadow price answers the question of, if I had just one more unit of a constraint, how much would my objective function value increase? Just to note here, it's in this example, I'm talking about having one more unit of constraint. So if we had one more unit of, let's see, so instead of 600, if we had 601 hours available to us for fabrication, we know that our objective function value would go up by $9. So this would now be 6,360. 369. Increased by $9. Okay. And similar to going up, you can also answer the question, if I had one less unit of a constraint, how much would my objective value decrease as well? Okay. So tying this together with the range of feasibility is, if you had, it's that by looking at the constraint on the right-hand side, and again, taking note that, okay, you have 600 and 480, what does that mean in the model? You're like, okay, these are the actual constraints themselves. It's saying that the range that you are calculating in the range of feasibility is telling us, that that range is valid for this particular shadow price. So just taking this first one for an example, you're like, okay, I have 600 hours available for the fabrications. I have 600 available. I can decrease by 440. 960. And you have 600. You're able to increase by 360. 960. So this tells us that the shadow price of $9 is correct as long as we're within this range. Okay. So if we had one extra hour, then we would have an extra $9 in profit. If we had two, we have 18. If we have three, we have $27, and so forth, up until we get to 960 hours, at which time we would need to rerun the model and we would have a different shadow price and a different range of optimality. Okay, so this concludes the cheat sheet workshop. Like I said, include all of this on your cheat sheet. Like I said in class, you're more than welcome to work with your team on the take-home portion, and I strongly recommend, if you feel that you need practice with the forecasting part, I recommend that you work on that take-home portion and have someone who feels more confident in the forecasting technique to check your work. And just capacity planning, and I can't stress enough that the midterm, there's a lot of critical thinking. So even though this seems like simple math here, be sure to look at the sample problems that I've given you in the Slack channel, because the way that the questions are designed in the midterm is designed to make you think in a way to be able to identify which one of these formulas, for example, you'd want to use. It will not be as simple as, this is the quantity, this is the revenue, this is the variable cost, here's the fixed cost, what is the profit? Like, that is a too easy question for me to ask on a midterm, so be prepared for that. Take-away in linear programming, you're not expected to create a linear programming model, but you are expected to understand what is happening in the model that I'll be providing you. You are expected to understand the various terms that we talked about. And you will see questions that come from the sensitivity report and also the answer report. The answer report itself is very simple. It just basically describes the answer that you got. So just review that real quick from the linear programming channel, and you should be set for that. All right. If you guys have any questions, feel free to ping me, and let's all stay healthy. Hopefully we will have class on the midterm. Talk to you guys later. Bye.